how can we do something for the community? How can we help rural areas and crisis areas or refugee camps, for instance, through the big crisis of the scarcity of potable water? So this is the research that I wanted to talk about today. Briefly, it is the solar water desalination system using the Fresnel lenses that we've been talking about. It is, again, funded by Solar Solution. Solar Solution is a company founded, actually, its CEO is Mr. Khalid Al-Kurd. He has immigrated from Jordan to the United States, and since then he has two companies, Solar Solutions and LVL2 Charging. Mr. Khalid and UNT, they've partnered to do this research to help the rural areas and probably project the results onto an operational system here in Jordan. So the objective, obviously, was to build a hybrid Fresnel lens and PV-based solar device that can distill water into potable water, salt water we're talking about here, not sewage water. We need to get rid of all the germs and microbes from the other types of water. The concept of distillation is not new, though. It can be very slow, energy intensive, and expensive. That actually what motivated us to do this project. So we wanted to make a self-sustaining system with little to no maintenance, modular, scalable, deployable to disaster areas or where water is scarce. And we needed to use any saltwater source available, such as seawater, river water, and so on and so forth. So the motivation, obviously, was to provide potable water for areas like crisis areas where we have floods and such, where we have refugee camps like the Zatari in here in Jordan, and for areas where we have scarcity of water, like in Africa, even here in Jordan too. So the basic idea of the system was to use the sun energy to evaporate water from salt water, and using this system that we've designed, this is just an early sketch of the system, and convert that steam into potable water to be used by consumers. The mission was to create the system and make it as efficient, scalable, sustainable, affordable, and portable as possible. We wanted to make it efficient to minimize the energy loss by 13% using heat recovery, and we also wanted to make it with a very high water recovery of more than 80%. Scalable, we wanted to make it as scalable as it can be, so any kind of user would be able to acquire it, small or large scale users. Sustainable, using their energy from the sun, either by using Fresnel lenses or PV electricity, so it has a hybrid heater that works on both. And we wanted to make it affordable with a payback period of less than 6 months, no more than that, no operational costs, just routine cleaning that is required. And we wanted to make it portable, so we designed it to be modular. Each and every part can be disassembled easily and quickly and transported to a different area. This is a quick glimpse of what do we have as of the desalination methods that are used around the world. I'm not going to go into details. I'm just going to mention all of them here. Most of them here. Those are not, I would say, heating or evaporation based, or those are just conventional, such as the reverse osmosis, the forward osmosis, membrane distillation, reverse electrodialysis, and the nanofiltration. We've studied almost all the available methods, and we've also studied the evaporative desalination methods, such as the multi-stage flash and the solar humidification, dehumidification. Those are the two methods that are related to our system. The problem with those methods, I'm not going to say problems, maybe the challenge with those methods is the size of the system itself, plus the cost of water from those systems. So actually, the initial cost of those systems is not as I would say cheap or affordable as it should be for a desalination system. So we wanted to choose some of those conventional applications, and we wanted to compare our work. We wanted to make them our, I would say, competitors, if you want to call it that. Doing our research,